Hi, I'm Sarah Yee, and I'm here to talk about sock systems for space. My path into this project started with Army ROTC field training in Long Rock and land navigation days, where I saw directly how sock fiber choice affected blistering, moisture control, and fatigue during 8-mile rucks and extended training blocks that later bled into my class time. And so the physical discomfort that I felt here pulled my attention and slowed decision making. I also saw this in training as an EMT, where we learned that triage depends on staying grounded and being able to prioritize quickly. So this made me super interested in socks, studying the composites of textiles, but also understanding that they're a critical performance component. As a national Pumse Taekwondo athlete and a trained ballerina, socks and foot layering have directly impacted traction, turns, and stability across different floor types. They're underestimated, and so this reinforced to me how these foot interface systems are a material choice. And now, as a mechanical engineering student at Harvard focused on human performance and soft goods systems, I've had the privilege to conduct biomechanics and motion analysis research on wearable devices at the Harvard Walsh Biodesign Lab, where I had the opportunity to shadow Amelia Mon, a functional repair fellow, and a former NASA soft goods intern. And so we've had many extended discussions because she actually worked on microgravity sock design. And so in spaceflight, clothing, as we know, is worn repeatedly and discarded rather than washed. And socks are one of the highest turnover garments, but yet one of the least measured soft goods systems, which I believe and my team believes makes them a practical target for operational testing. So my project is asking a focused question: can a wool sock safely extend wear duration compared to a standard synthetic sock? So we're running a randomized crossover extended wear study where participants will use each sock type up to 24 to 48 hours and then stop at defined comfort thresholds. We're collecting microclimate data, structured comfort reports, and durability indicators during a short confined movement task that is directly dependent on what we've seen from the literature. This is a conservative replacement interval model for mission scenarios, and generally a pilot feasibility study focused on effect size and building reliable protocols. So alongside my engineering work, I had the opportunity to proctor the Harvard First Year Arts program, and I've contributed to the on-display installation for the UN, which was exhibited at Harvard Art Museums using found materials and constrained gravitation. So through these experiences, including professional media work with Teen Vogue and the Sacramento Bee, I believe that the civic science and public communication side of this project will show that socks are both functional, fashionable, and for space. I could talk about space sock systems all day, but I really want to emphasize that these high-use turnover components are really where the real gains are hiding. I hope to receive your support, and thank you so much for your consideration.